But let me just share the screen. Wait for 2 minutes. Let me take out the homework. I just want to discuss one thing. See, Maha, this part was correct. The writing of dimensional formula and all that you have written very well. See, just one thing. Whenever a question says that you have to show both the sides, like prove something, so you have to show your left hand side and right hand side both. Okay, like it is saying energy per unit volume, you have to show that it is equal to pressure. This part is fine, but this is just one side. That yes, energy per unit volume. You have shown that this energy per unit volume part is equal to this, which is ml to the power minus 1, t to the power minus 2. How is it showing that it is equal to pressure? So for pressure, you have to separately show, na? Like pressure is equal to force divided by area. And then when you're dividing force and area, you're getting the same thing. So what you can do, you can show first what is energy by volume and get the dimensions. And then calculate for pressure and get the dimensions. And then you can say both are equal. Or you can do one thing, you can keep on equating it from the starting. That energy per unit volume is equal to pressure. So then you write down for energy and you write down for volume, and for pressure you write force and area. And at the end you will see ml to the power minus 1 t to the power minus 2 is equal to ml to the power minus 1 t to the power minus 2. So in such case you can say hence prove they are equal. But write down both of things. This is not showing that it is equal to pressure. It is just giving you the value or the unit of all these. Got it?
Yeah, okay.
Okay. So I've submitted the sheet back. That's it. The rest of the part was correct. Let us start with the dimensions. Okay, Maha. So see, we discussed the various physical quantities. We have been solving it, and we have seen what are fundamental quantities, what are derived quantities, and that is what we have been studying. Right. Now, look, few 7 basic fundamental quantities we had seen, and using these, we were making up our dimensional formula. Remember, MLT was our basic skeleton structure based on which we were putting the rest of the things.
Yeah.
And what were 2 supplementary quantities? Can you tell me those 2?
What?
2 supplementary. These were 7 fundamental. 2 supplementary quantities were also there. Angles. Plane angle and a solid angle. Remember? 2 supplementary quantities we
Oh,
discussed.
yeah.
Okay. Anyways, let's continue with this. So few things we discussed, and I told you few of them you should remember, because when you must be doing the assignment that time also you must have felt that velocity, acceleration, these are very basic, and these will
Yeah.
be right. So distance and all, speed, acceleration, momentum, force, till force we had seen. So see, let us see for the pressure. Now see, force is mass into acceleration. Acceleration is LT to the power minus 2. This is force. Divided by area is L square. So that is M L to the power minus 1 T to the power. SI unit is pascals for pressure. See, you can simply use Newton per meter square. So this will become dyne per centimeter square. All these are, both of these are valid for, but SI unit, it's better if you use pascals. And this I already told you, if you have any sort of energy present, work done, and the rest of the types of energies, they have the same dimensional formula, ml square t to the power minus 2. So remember work done. And I think, Maha, you have to appear for the NEET exam also. You're planning to appear for NEET.
Yeah.
Yeah. So in the NEET exams, no, these dimensional formula, this is also important from NEET perspective. So in NEET also, you have, when you remember few of the formula, directly you have to put it. See, in the NEET and your CBSE's 11th class portion, there isn't any difference in the questions that will come from dimensional analysis. From the next chapter, the questions differences and all might start, but basically you have to go with your NCRT. So this chapter, do it perfectly so that this helps you for the rest of the chapters also. So,
Okay.
Maha, did you write the 7th point and this note point, or you've put written till work done only?
Only work done I do.
Okay, just write down these 2 points and I'll show you some questions, how to solve some questions. Okay.
I'm done.
Okay, ma'am. Let's see now how the questions come. Basic formula writing, you have understood how to write the dimensional formula. This isn't, these are not all the quantities that are present. We'll be seeing different quantities more. This table is a huge table, but in between, let us just see 1 or 2 questions, because these were the basic ones which were required. And in the questions that I have selected, only these will be required. The first, why I have separated both of these is that you should understand the first part that we have done. This was the very basic part. Okay, the first column which we have completed, that was the basic part, and that has to be remembered by you, most of the portions from it. Second part we'll be doing, from there you need not remember anything. By the end of the session, you will know all the formula by yourself. So see,
Okay.
how do we find out the questions? There's a formula given, F is equal to G m1 m2 by r square. Let me just give you a brief of this. This is basically the formula from your gravitation chapter, Newton's law of gravitation. So whenever two objects are present, you need to calculate, whenever two objects are present, you need to calculate the force between them. Like right now, even if you are sitting, your laptop, both of them are resting at a place, they are exerting force on each other. That's why you are stably present. So all these things you will see in gravitation. That is, what is this G? This capital G is basically the gravitational constant. So we have to find out its dimensional formula. Now, F is the force, M1, M2 are the masses present, R is the separation. Separation means if this is M1, this is M2. So separation between M1 and M2, that is what is R. So we need to, our task is to find out capital G. So look, simply the way you find out the value of x in an algebraic equation, you have to find out the same thing with the help of dimensional formula. Like if I have force, my formula right now is F G m1 into m2 divided by r squared, right? Now our task is to find out this g. G is missing for us. We want to find out the rest of the things. So let us do one thing. Okay, if g is missing, it's okay. We know the formula for rest of it. So Maha, tell me, for force, what should I write?
Mass into acceleration.
Yes, so dimension should be, I told you to remember for force,
ml t raised to.
yes, ml t to the power minus 2. It's okay. These will be clarified after completing lots of questions also. But try to remember these. See, these will be utilized everywhere. That will not help you just here. See, these are the things that make your entrances and your class boards normal exam different. If you are going in your competitive exams, you just have to solve the questions within a limited period of time and very quickly. So it's better if you remember it from the scratch only, right? Because if your target is set, just prepare for it, right? Now G is missing. Let's put G as it is. M1 mass is M only. Second mass is M only. What should I write for R square?
That's what we are finding. No?
No, we are finding G, capital G. It's a constant. What was R? Look,
Separation.
separation. So for separation, which is suitable?
Distance, right?
Exactly. So L is for R. This is R square. So it will become
L square.
exactly. This is L square. This is it. That's it. Now see, you just have to take it like your equation, simple like equation. If I give you X, so how do you solve? Like that we have to find out. Now see, this is ml square here, ml t to the power minus 2. This L square will be multiplied here. And these two masses, they will be divided. That's how we have to find out G, right? This will be multiplied. They'll be divided. Yes.
And can't you like multiply those masses?
Yeah, we can m square, same thing. We can multiply these masses also. This will become m square. This is also correct. But same thing, see, this mass will cancel one of the masses. So what will be the formula, final formula? Yes, Maha, tell. What is the final formula?
L raised to 3
L
t
raised to,
minus 2
that's it.
pi m.
By m, no. Your task is to write MLT only. Then
Oh, okay. Then it will be m raised to minus 1.
exactly. If your m is coming in the denominator, it's okay. You make it to the numerator. So this is the final answer. Got it? We'll see one
Yeah.
more question based on this. Try to solve this by yourself only. Write it down. Okay. Everything is there on the screen though, but try to solve it by yourself. Wherever you get stuck, everything is present on the screen. We'll do one more question.
I didn't know this done.
Done? Have you written this, Maha?
Yeah, the upper part is done.
Okay, let's move to the next question. See, now this is again a formula given. So this formula is F is equal to, the symbol is pronounced as eta. So F is equal to eta A dV over dx. Now let us see what are these variables. Basically, Maha, when you come to the fluids chapter in your second book of physics, so between the layers of fluid, when you have to calculate the force, that time this is used. Anyways, F is the force. This symbol eta is the coefficient of viscosity. This is called as, you don't need to remember this, even if you forget it's okay. This is the coefficient of viscosity. Now, A is area, dv is the change in velocity. Now, just one thing, Maha. After this chapter, before starting with motion in a straight line, I'll be teaching you the mathematical physics, because I hope by now you know that in physics, some mathematics part is required, right?
Yeah,
And that part is not necessary for you to know in your maths or bio or any subject. That part I'll teach you separately if you have maths or if you do not have maths, okay? And that much
okay.
of physics will be used in your 11th also, and that will be used in your 12th also. So we have to study that. Without that, your physics won't be. And anyways, what do you have? PCB?
Yeah, just PCB. No
Just
maths.
PCB. Okay. Anyways, even if you have maths, you don't have maths right now, you don't have maths, that's okay. That won't affect your physics in any ways. Just practice those portions, whatever I'll tell you. So when we'll be doing that time, I'll tell you in detail. Right now, I'm just giving you a brief. When we have a change in two quantities, like initially something is there, then there's a final quantity. And if change is visible and it's not very small, if the change is finite, like let's say 2 seconds minus 1 second, that gives you 1 second, or 5 seconds minus 3 seconds, that give you 2 seconds, like this. So for a significant change, whenever you have your change is significant, means it's not very small and it's not very big. For change, we use the symbol delta, like this. You will see the symbol delta V means the change in velocity, like this. If you see the symbol, this means change in velocity. So means you have to
So
calculate
it's
final.
same as DV, right?
This D,
Yeah.
that's what I'm telling you. When you have a very, very, very small change, means that is so small that we can neglect it. But in physics, everything cannot be neglected, right? So for those purposes, we use this symbol D. This also means the change only, but this change is infinitesimally small. This is so small. Like if I give you example, 0.0000, and you add many zeros and then just put a number 1. If I tell you this is the change, we'll just simply say if this is the change, that is 0 only, right? This is what we consider usually.
Yeah.
In But no, in physics, when you have to deal with such values, you will not ignore it. You cannot neglect these values. So these are represented by these symbol D, and they cannot be solved using the simple mathematics that you have studied, multiplication, division, addition, subtraction. No. For that, you have calculus separately that you have to study. So this is what is meant by when this dv dx is given. Don't get confused that d is some distance or some length. This complete
Okay.
symbol is change. Okay, that complete symbol is change.
So
For
for minute changes, it's D is used.
yes, right. Okay, when very small changes there, we use D. Or the change is very slow. The something is changing over a very slow period of time. For that purpose, I'll teach you this part again in detail. Don't
Okay.
worry. Now let's come in the back to this question. So this says F is equal to eta A dv, this whole thing divided by dx. Now we have to find out the dimensions of coefficient of viscosity, that is the symbol eta. So let's do one thing. Let's write down the rest of the dimensions, and then we can cross multiply and get the value of eta. Or we can write eta directly from here only. What will be this symbol? F multiplied to dx divided by area into dv,
D.
right? Now tell me the dimensions. F, what should I write?
Force was ml t raised to minus 2.
Yes, mlt to the power minus 2. For dx,
Going. Dx was this thickness, right?
yeah,
So
thickness. This is it, thickness. How would you measure thickness if I give you some thickness? Try to figure the
by
unit.
distance, right? Length.
Distance, like, right.
So
So it
L
will be
only.
L. Correct. Like if I say thickness of a book, you will tell me this is, let's say 3 inches thick, right? Like this
Yeah.
is how we answer. So thickness is distance. What about area?
What's
The
area?
first question which we did.
Oh, that is also a length.
Area is same as length.
No, no.
Think. What's the formula of area of a square, rectangle? Is it just length?
No, it's square.
Right.
A square.
L square. Check your notes. In the first class, we have done the area, volume, density. These were the
Oh
first.
yeah, okay, okay, I found it.
Got it? So
Yeah.
area is L square. And velocity is
Velocity L raised to 1, t raised to minus 1.
yes, t to the power minus 1. See, Maha, did you see? Till now, no new variable was introduced. Only the
Yeah.
6, 7 variables which we discussed, we had these only. But if you do not remember them, you will have problems in solving the question. First, just practice what we have done in the class. Without that, you'll not be able to clear the exams with a good score. This is the easiest chapter. So what you do after the class, study the class notes, then practice the
Okay.
homework questions. That's it. That's enough for the first day. Then you have full time left. Whatever subject you have to study, you have bio, you have chemistry, study that, and then study physics from the reference books also. That then you will have time. But these things are basics. Homework questions and these, because see, Maha, everything cannot be completed in the class. So rest of the questions which are left, I'll give them to you as a homework, so that wherever you
Yeah.
will face difficulty, we'll discuss it. But before anything, whatever I have told you to remember, remember those. Like area, distance, velocity, forces, these should be remembered by you. Otherwise, your time will be wasted. Okay.
Okay.
So see, this L will cancel one L. This L will cancel that L also. So now you tell me, Maha, what should be the final answer?
Um, ML
ML.
and then -3.
This
Sorry, no. Yeah, -3. No, subtraction. So -1.
minus 1. One more error. This L is in the denominator. It won't be L.
Oh yeah.
It
So
will be
L
minus.
raised to -1.
Yes. And see, this T will go up. So 1 minus 2. Minus 1. This is it. Got it?
Yeah.
Practice. I'll give you some questions from this today. Try to practice it. Okay. Write
Okay.
down this. Then we'll see some more quantities.
I'm there.
Okay, let's continue with this table now. So these are the quantities from this. You don't need to remember much. These will be done through the chapters. But before that, that was important. So revise each and every question of that. Okay, from here, see the formula and then revise. When you're studying, just see the formula. First, what's the formula? Because formula you need not remember. But construction of dimensional formula should be done by you. Okay? Okay. Now see what is angular displacement. Basically, if let's say this is an arrow, this is going from this to this. So there is an angle that has swept. This is called
Yeah,
angular displacement. Whatever you study in straight line, everything has an analog in rotation. So all these things are a part of your rotational motion, like when the fan is moving. So fan is also covering some displacement, some distance. But how will we measure it? We'll measure it by seeing the angle that is swept by the blades. So that is what is angular displacement. So formula of angular displacement is same as that of your angle. If you remember in class 10th, till class 10th, you have done this. Theta is equal to length of the arc by the radius of arc. If you just have an
yeah.
arc, yeah. So see here the dimensional formula will be length is L only. Radius is also L. It is dimensionless. Now this is important. I will tell you one thing. Two quantities I'm going to tell you that are very helpful. One is this angular displacement. Remember this. And one is strain that we'll be doing. Now, this is dimensionless. It has no dimensions. Why? Because this will be L to the power 0, M to the power 0, T to the power 0. It is dimensionless. But this is that quantity which still after being dimensionless has the unit of angle. What was the unit of angle? Plane angle. I told you a unit. Check through your notes. You have written it.
Theta only.
Unit,
Oh,
unit,
units, radian.
radian. Okay. Unit is radian. We write it as RAD. This is how we write. So if the question says mention a quantity which is dimensionless but has a unit, so keep it in your mind angle. And if it is a question from your NEET, because this question has come in your NEET exam also, and this keeps on coming in the school exam also. So keep angle is a quantity that dimensions will be cut, but unit will be preserved. Okay.
Okay.
Like your distance changes over time, you get velocity. So here also angular displacement keeps on changing, so you get angular velocity. Means this angular velocity by this angular displacement by time. So angular displacement is dimensionless, L to the power 0, but velocity, this time has a dimension T. So for angular velocity, this part will be 0, LL will be cut, but this will simply
Yeah.
be T to the power minus 1. Okay, mass isn't present here. This becomes radian per second, means radian divided by seconds. If you remember, we had acceleration also. What was the dimension of acceleration? Try to recall without looking. It's velocity by time. Okay,
Yes, it was speed.
check now. Now look into the notes. See what was acceleration. Tell me.
Meter per second square.
Dimensions, not the units. Dimensions.
It was L raised to 1, T raised to minus 2.
Exactly. L T to the power minus 2. Remember, okay? In the next class, I'll be asking you. Okay? See, angular velocity is T to the power minus 1. It is getting divided by time. So when this time will go up, again -1, -1 makes it -2. So this has the dimension t to the power -2 only. And for angular acceleration, this becomes radian per second square because now time is getting divided again by time. So radian per second square. Got these three? Fine.
Yeah.
Write it. We'll see some other quantities. Have proper scale with you. Just make this table and we'll be completing this table.
I'm done. Done.
Okay, Maha, let's see some more thing. Now there's a quantity moment of inertia. It's like mass in your rotation. The work mass does in your normal translation motion. This is an analog in your rotation. What we have to focus on is again the formula. I is equal to mr square. M is the mass, r is the radius. Now, Maha, tell me, what should I write for the dimension formula? For m, what should I write?
Mass will be M only.
Exactly, mass will be
And
m.
then radius is length, so L square.
L square, exactly. So we'll just multiply it. M L square t to the power 0. That's it, right?
But then what about inertia? No, nothing is there for it.
This is exactly what we're getting, no? For inertia, we are calculating.
Oh, okay.
Like your here, alpha was equal to this. I've written this I again here. I is equal to this. Okay. This is kg for mass, meter square for radius. Now, the way we have force in the normal translation motion, you have torque. Torque is radius multiplied to force. Now, what is radius?
Wait. Ma'am, what's torque?
Torque is basically rotational force. Like your force, see, we are just seeing the analogs. Whatever you will study in linear motion, no, in a straight line, in rotation, some things will be different. Like instead of mass, you will use moment of inertia. Like your torque, like your force, you know, force, push, or a pull. So when something rotates, like if your fan is rotating around an axis, then that time force is not acting. The force which
Yeah.
is rotating it is torque. Okay.
Oh, okay.
So yeah, tell me the dimensional formula for R. What should I write?
L only.
L only. R is the radius. And force, again force comes.
What's force? Force is, oh, MLT raised to minus 2.
Yes. M L T to the power
Now,
minus.
what's the symbol above with the arrow?
A symbol of
Like, on
this.
above R and F, there's an arrow, right? What does it
Oh,
symbol?
okay. That is a vector. See, that's your physical quantities are of two types: vectors and scalars. So that is a big, vast topic. This symbol basically shows that it's a vector quantity. In short, it means if a quantity has a direction also associated, like force has a direction, but mass does not have any direction. For masses, you can have just the mass won't be directed towards somewhere. So the quantities that have direction are called vectors, but this is a big theory that you have a full chapter on it. When you see these arrows, just have it in mind, this has a direction. Okay, this is also a vector only.
Okay.
You can avoid that. So final formula will be m l square t to the power minus 2, and the unit will be Newton multiplied to meter. Now tell me the answer for angular momentum. This is the formula.
That's length only. Or like,
That is this L. No, L is actually the symbol for angular momentum.
oh, okay.
When I put
So
equal
R,
to, means this is this quantity. Like torque is this. I is this. This is the formula. R cross P. So R
oh,
is
okay.
your distance. So it will be L only. Remember what is MV?
What?
MV, momentum. Check in the previous part. Momentum. Have you
Oh,
written
yeah.
momentum anywhere?
Yeah.
Yeah,
In
so
this right
formula
dimensional
was
formula stuff.
mass into velocity.
Yeah, mass into velocity. So it's like ML T raised to minus 1.
Exactly. MLT to the power minus 1. So the formula of angular momentum will be M L square T to the power minus 1. Got it?
Yeah.
So this will be kg See, this is mass into velocity meter square per second square. So SI unit also, this isn't very important for momentum. You write down these three first, then I'll discuss anything else. These are clear, Maha?
Okay.
Okay, Maha, one thing, see, you need to practice. Practice, look at the formula. I'm telling you, you don't need to learn right now. It's okay if you don't know the formula, the symbols, the meanings of many things will come right now, because it's just the starting, right? But writing of dimensional formula should be clear, and the topics which I have marked, those formula parts should be remembered by you. Okay,
Okay.
write it till here.
I'm done.
Okay, Maha, actually the time is up. So I think in the next class, let's meet. And please try to join the class a little on time. Okay, I think today also it,
Yeah, sorry.
it got delayed by 10 minutes. Okay. Okay, Maha, you can leave. Please do the homework. We'll discuss it in the next class now.
Ma'am, is the class tomorrow or something?
You have not received the schedule yet. No, I think it's on Monday, Wednesday. Your classes are on Monday, Wednesday. I'll
Oh,
tell
okay.
the team to contact you once. Okay.
Okay.
All right.
Because I won't be able to join tomorrow, that's why.
Oh, no, no, you don't have any class tomorrow. Okay.
Okay, thank you.